In this lesson, the objective is to perform composition of linear functions, and we are going to be applying this to verify linear inverses by composition, which we shall do in the next lesson. So let's look at the vocabulary. So we start with composite function, and this is the result of composing or combining two mathematical functions together so that the output becomes the input of the second. And this is the notation here. So I want you to note that you're going to see this notation here, and it's not very, this one it's not very common. Let me go back here. So you're going to see this notation. It's the same as this notation, same as that, and we read it as f of g of x, f of g of x. And so now let's see how we can apply that to do some examples. So these are the steps to follow. So rewrite the composition in a different form if necessary. For example, f of g of x is the same as that. So you can do that if you need, and then you replace each occurrence of x found in the outside function with the inside function. So here we have two functions, and the functions are f of x and g of x. So we are told to find f of g of x. So how do we do that? I'm going to take the f function, which is 2x plus 4, and what I'm going to do, see here, what I'm going to do, and I'm actually going to use a different color so that you see it. Where there is x, I'm going to replace it with the second function, which is g of x, because g of x is the input instead of x. So where there is x, I replace it with g of x, and g of x is negative 4x plus 3. And then I just continue with the same function I had before for f of x, which was minus 4. And then all I need to do is to simplify that. So that becomes negative 8x plus 6 minus 4. So we get negative 8x plus 2. So, and I can write my notation there so that I get used to it. So that will be the answer right there. So that will be the answer. Okay, let's go to the next one. Now we are doing g of f of x. G of f of x. So how do we do that? So I start with the g function. So I start with negative 4. Where there is x, I'm going to put the other, where there is x, I'm going to replace it with 2 of 2x minus 4. And then I'm going to write here, I'm going to write plus 3. Plus 3. Because the g of x had a plus 3. So I just simplify. So minus 8x plus 16 plus 3. So I get negative 8x plus 19. And this is g of f of x. So that's my answer right there. And is g, so is g h of x. And I can see here got the wrong notation, the notation here. What we mean here is f of g of x is not equal to g of f of x. So not the same thing. So I want you to note that. Okay, let's do another example here. So we are given f of x and g of x. So we start with the f function. So I start with the f function. So this is going to be 3 instead of x. I'm going to replace it with, instead of x, I'm going to use 2x minus 7. And then I continue with my function here. So this becomes 6x minus 21 plus 4. 6x minus 21 plus 4, which is equal to 6x minus 17. So I get f. It's good to keep writing this notation because it's new to you, so that you are going to remember it. Okay, now we go to the next one, and the next one we are told to find g of f of x. So to find g, so I start with the g function. So this is going to be 2. Instead of the g function, I'm going to write 3x plus 4, and then 3x plus 4, and then I'm using the g function, so I still have minus 7. So what do I get? 6x plus 8 minus 7, and that becomes 6x plus 1. So I can write my function, my notation here. So that's the answer. And again, you see f of g of x is not the same as g f of x. Now let's go to another one. This one here, you see what I have here is different because I have a number right here. See, here I have a number. The other one I had just a variable. So what do we do? I'm going to start with what is inside. So I'm going to do f of 2. And what f of 2 means? It means wherever there is x in the f function, I replace it with 2. So this is going to be 2. This is going to be 2 and 2, and this is going to be 2. And then we go back to the blue. So 2 minus 3, and I get 4 minus 3, so I get 1. So now what does that mean? I'm going to do g, because f of 2 is 1, see, all this is 1. I just need to do g of 1, so I get the g function and I replace x with 1. So this is going to be, it's going to be 1 plus 5, so I get 6, and that's the answer. And let me do this. I'm going to make a line here. Let me confirm my answer here, see whether what I did is correct. I'm just going to do it the way we did it on the previous example. So I'm going to do everything, and then when I'm done, I'm going to plug in 2. So I need to do g of f of x. So I take the g function, so, and instead of the f of x, instead of the x, I'm plugging f of x. So it's going to be 2x minus 3 and plus 5, which is equals to 2x plus 2. And now I just do g of 2 g of f of 2, which is just plugging 2 to this equation, which is going to be 2 times 2 plus 2, which is equals to 6. So I know my answer is correct there. So, but see, this is a lot of work doing all this. Now, let's go back here, and we're going to do the second one here. So I'll start with the inside. So I do g of 3, and g of 3, I take the g function. So it's in where there is x, I plug in 3. So it's 3 plus 5, which is 8. Then I just need to do f of 8, which is going to be, I take the f function, I plug in 8, 2 times 8 minus 3, 2 times 8 minus 3, so I get 16 minus 3, so the answer is 13.